One of the reasons we even learn about acids and bases so much in healthcare is to get this idea of buffers. And so a buffer solution is one that resists changes in pH. We talked about blood, we talked about it having this really sensitive range of pH that it really has to stay in, right around 7.4. If our pH should change a lot, that can be life-threatening. And remember that our bodies are really resistant to changes, right? Just because some acid should come along and be introduced to our bloodstream, or some base should come along and be introduced to our bloodstream, our physiology has the ability to resist that, right? pH can, under normal conditions, be held at 7.4, even if there's some external stimulus that's trying to make our blood pH rise or lower. And this is done through buffer solutions. The body has to respond quickly. It's proven to respond quickly. This is done by a buffer solution. And so a buffer is a system that resists changes in pH when an acid or base is added. And it acts like a sponge for whatever new acid or base comes along, or a shock absorber, if you will. If H plus is added, this would cause pH to drop. The buffer soaks it up, right? H plus comes along, the buffer absorbs it, and there's no change in pH because it doesn't make the body more acidic. Same thing happens when base is added, right? The buffer releases H plus, neutralizing the OH minus, right? We talked about that when you have H plus and OH minus next to each other, they nearly to 100% will cancel out, and that's how the buffer is able to absorb base, for example, to say. It's not totally accurate to say that, but that's a good way to understand it. It'll either absorb acid H plus that's added, or it'll absorb OH minus by releasing H plus. And in either case, whether it sees new acid or new base, it keeps the pH stable. And so here is the classic example. This is the buffer system that the body uses in order to control pH. This is a carbonic acid, bicarbonate, and it's really governed by CO2. It's shown here as carbonic acid, bicarbonate, just for simplicity, but really it's governed by carbon dioxide. When there's too much acid, bicarbonate will scoop up that acid. And so this is the right side going to the left. We have bicarbonate in the blood, it sees some new acid show up, and that neutralizes it, and there we are, right? So HCO3 gets some H plus, neutralizes that. If there's too much base, well, the carbonic acid can give up a proton, give up its H plus, and it goes to the left, and then we have that base that's absorbed as well. And so here we can see the body's buffer systems in a bit more detail, because the reason this is governed by CO2 is because CO2 in water will make this carbonic acid. So if we increase the amount of CO2, we end up making acid, right? So CO2 and acidity should be related in your mind, right? When we get more CO2 in the lungs, that's going to make things more acidic. And so this is how the lungs are associated with the pH rate and adjustment, right? The kidneys are involved as well. That's where our bicarbonate reserve is, and that's a slow but powerful response. The kidneys take longer to adjust our bicarbonate levels. This is more like hours or days. Blood becomes too acidic, the lungs breathe faster to blow away the CO2. And remember that while CO2 is associated with acidity, remember that when we're breathing, we're getting rid of CO2, right? So the faster our breathing rate is, we're breathing in oxygen, exhaling CO2. So keep that in mind, right? If it becomes too basic, breathing slows down, retains CO2, that makes more acid, and there we are, right? This is able to be studied in a lot more depth if you choose to go there, but in the most basic sense, knowing that this is a buffer system, it's this bicarbonate carbonic acid buffer. It exists to remove or add H plus in order to maintain a proper pH environment for the blood, and that it's governed by the lungs and the kidneys. That is what's important to know for this course.